Okay, so we've found how to find maximum and minimum values given a function. We're now going to put that to use in word problems. I've got a couple of examples here, kind of the classic of classics. Farmer Brown has a certain amount of fencing, 200 meters in this case. He wants to fence in a rectangular area. In this case, it's beside a creek. So basically that means he has to fence in 3 of the 4 sides only. And what's the maximum possible area to be fenced in? So the fact that it's a rectangle, of course, helps. If we had a variety of options, it'd be a lot more work here. So to make this a rectangle, we want to recognize what our possibilities are here, and then once we have a function to represent the area, we can maximize it the same as we've been doing. So it's not going to be too bad. We've got essentially what we have to do is we have to establish what length we're going to put here. We'll have the same length down here, although the creek doesn't look perfectly straight. We're going to assume it is. And then whatever the remaining fence is will come down the side here. So because I don't know what my values to be here, actually that's a bad idea. I'm not going to call it x. I'm going to call this the width. So the width of fencing goes this way. I'm going to use this as my length of fencing. And so now I'm going to represent this in terms of W as well. Well, we've used up one W here, which means I have 2 W's being taken out of the 200 meters that are available to me. And so this will be 200 minus 2W. W. Now, how do we find area? Area is length times width for rectangles. The length in this case is 200 minus 2W. And the width is, of course, just W. And so if I expand this, yeah, I'm going to expand it. 200W minus 2W squared. So that becomes my function now to represent the area. If I want to maximize that, as we've done before, we have to take the derivative. So I'm really looking for A prime here. A prime, pretty easy, is going to be 200 minus 4W. Okay, so just take the derivative in terms of W now instead of in terms of X. It's exactly the same thing. I take the derivative, the W has an exponent of 1, 1 times 200 is 200, 1 minus 1 in my exponent leaves me with 0 W's. Subtract 1 here, I'm going to have a W, and of course negative 4. Now, maximums and minimums. I guess I could have started with this. Maximum means, again, generally, the derivative is 0. Now I've got the derivative being A, or A at W, I suppose would be a nice way to write this as well. But basically 0 is my either maximum or minimum. It happens that in this case, maximum is what we're going to get. If it isn't, then it doesn't really make the question won't make any sense. And so if we solve this, subtract the 200 over, divide through by the negative 4, and that will be my value for W, which is 50. So what that means is, what's the maximum possible area is what I'm being asked. Sometimes you have to watch the question itself. It could ask us what dimensions will give us the maximum area. It can also ask us what is the maximum area. In this case, they're actually asking for the area. And so the area is the length times the width. The length is, again, 200 minus 2W times the W value that we know. So this is 200 minus, and of course you could have figured this out just kind of logically and finish the question that way as well. If I'm using 50 here, 50 here, I have 100 here left. And so I'm going to get 100 times 50. Those are the actual dimensions. And the length, the area ends up being 5,000, and I guess meters squared in this case. And so because it's a word problem, I should probably finish it appropriately and actually answering the question. Therefore, the maximum area is going to be 5,000 meters squared. So that's kind of the one class of problem. This is sort of another one. You have a piece of sheet metal. In this case, I wrote down 30 by 50. And in order to create the bottom of a safe box, or a small safe, we're going to cut corners off of this. And the corners are going to be squares. And so the amount to be cut is basically what we have to represent here. And I'm going to go ahead and use the letter C as the cut. Obviously, any value you want to use there. If you want to use X, please feel free. If you want to use L to indicate the length that's going to be cut off, that's fine as well. And so now what I've got is a length, sorry, my pen's acting up a little bit here, a width of 30 minus 2C, kind of this leftover part here. This leftover part here is going to be 50 minus 2C. And so what you want to visualize is what happens when I fold this up. I'm going to fold along these dotted lines to make the bottom part of my safe. And so this ends up being the wall that comes up towards us. This is the 30 minus 2C. This is the 50 minus 2C that make up the base. The height then, when you fold this up, is C. So my volume will be length times width times height. Count the length as whichever one you want. I'll go 50 minus 2C, simply because that's the orientation I used for the last example as well. This is 30 minus that same 2C, and the height is C. And now we're going to multiply this out and take the derivative. I'm going to sort of semi-cheat here, but I see that I think that I would rather just multiply the C in here first. Not that it matters, of course. If you're multiplying three numbers, you can multiply them in any order. And so I get 1500C minus 100C squared minus 60C squared plus 4C cubed. And we'll simplify this a little bit more, rewrite it 4C cubed minus 160C squared plus 1500C. Now again, as was the case last time, and as is always the case, as soon as I need to find a maximum or a minimum, I'm talking about dealing with the derivative. And so volume prime, or the derivative of the volume, is going to be the derivative of this. I'm going to have 12C squared minus 320C plus 1500. And the derivative has to be 0 to get my optimal. And so I've got 12C squared minus 320C plus 1500. This is not divisible by 12. Everything's divisible by 4. I'll have 3C squared minus 80C plus, let's see, 750, 375. And so I'm looking for two numbers to multiply to 15, 1, 2. Let's go ahead and pause here, and then I'll come back with this. Actually, we'll keep going. When I look at this, I'm going to suggest that I probably don't know how to factor it. It might be able to be factored. It's not really that important, though. Of course, what I want to be able to do is, if I can't factor it, I want to use, and probably a good idea to go ahead and remind people of this. The quadratic formula will help me actually solve this, regardless of whether it is factorable or not. Okay, now let's start by saying, typically we make x equal to negative b plus or minus square root of b squared minus 4ac. In that case, of course, c is the 375, a is the 3, b is the negative 80, and c is the 375. This is not the c that's actually in the question, that's just kind of the general form of that calculation. And so now I'm actually looking for the value of c here. So I'm going to write my real c is going to be equal to negative 80. Okay, so again, I'll back this up a little bit here. This is the form of the calculation to be done. And those of you who had me last semester know that I kind of like to do things this way. Just remove all the variables, put in brackets. I think it's important that you put in the brackets so we don't make silly mistakes with negative signs and so on. And then b itself is negative 80, we said. So get negative 80 there. We get a negative 80 in here. A is 3, so we get a 3 here and a 3 here. And c is 375, so we get a 375 in here. And assumedly I don't have to go through this in too much detail. We have 80 plus or minus the square root divided by 6. Okay, and this time I will pause and come back with answers. Okay, so it looks like this is 1900 in the root. Take the square root of 1900 and we get a bit of a messy answer. Got 43 point, let's say 59 divided by 6. Extend that page. And so C is either the addition here or the subtraction. And I like the way this one's working out, even though it doesn't seem like it's going to be a nice even answer. It's going to be a nice answer to discuss. So 80 plus 43.59 divided by 6. So C here is 20 point, basically 20.6, almost exactly. And over here, we have 6.07, let's see. So this was actually 0.0, 6.07. So a couple comments here. We're not going to worry so much about scientific notation and so on. Obviously, if I have the number 80 in my question, technically that's that's a significant number of only one. I don't know how much you got into this in science and so on, but for our purposes, we'll basically keep 2 decimal places where appropriate. It's worked out to 20.60, so that's fine. So the 2 answers I have are these 2. And maybe just the last comment. I rounded off to 2 decimal places in these spots, knowing that it was the last step of the way. And same sort of thing here, actually. I knew this was basically 1 step from me getting my final solution. Throughout a question, if you're going to round off, make sure it's 4 decimal places or something. Ideally, at this level, we should be typing this thing in exactly as it was, not even doing this, but just for presentation purposes, I think this is probably a little easier for people to follow. If I were actually a student in the class, I would have punched in 80 plus root 1900, get the answer, divided by 6, write the final answer, no rounding off at any point until the final answer. So, sorry, last thing now, 20.6 and 6.07. So the 2 answers we found were 6.07 or 20.6. Normally, if we have 2 answers, one of them isn't legitimate. Sometimes it'll be a negative number and easy to recognize. If I tell you to cut a negative amount off the corner of this page or the corner of the sheet, obviously that's not possible. In this case, the 20.6 is not possible because of course we only have 30 inches here to work with. So if we cut 20 in, we end up overlapping them. We actually end up, of course, with this one trying to cut to that point, and this one trying to cut to that point. And of course, that's not legitimate. So what we're going to do is basically cut essentially 6 inches, 6-inch corners off of, or 6-inch squares off of each corner. And in this case, what is the length that should be cut in order to maximize the volume? The question is, what should we cut, not what is the volume? And again, just paying attention to that is fairly important. Therefore, we should cut, oops, that's not spelled correctly. We should cut 6.07 by 6.07 inch squares from each corner. Okay, so in all these questions, as soon as you see maximize or minimize something, it could have been minimized as well, I just happened to choose 2 examples that were maximize. As soon as you see maximize or minimize, find the formula for the question if you had numbers. Okay, so if it said to me, cut off 3 squares that are 3 centimeters by 3 centimeters, or sorry, 3 inches by 3 inches from each corner, I would subtract 3 here, subtract 3 here. I would get 24 as my length, 3 here, I get 44 as my length here, and then my height would be 3, multiply 30, or 24 by 44 by 3 to find my volume. So we do exactly the same thing here, except with the variable still in there. And then once we have the formula in some sort of a simplified form, take the derivative of it and make it equal to 0. Okay, so as soon as you see maximize, minimize, you should know that those are the steps to do. Develop the formula, take the derivative, make it equal to 0, solve for whatever your variable is, and then again, final thing would be answer the question that's asked. Okay, so I'll sort of include that as the last slide, maybe just a quick little rundown of those things I just said, and good luck.